In ratio tests, we use limit n to the infinity an plus 1 over an, and to make it short, we just times 1 over an, and we'll get the answer as p. So if the answer is less than 1, it is converged. It is more than 1, it is diverged. If it is equal to 1, it is inconclusive. So here is our first example, 2 to the power of n over n factorial. So to do this question, we just put limit n to infinity to the power of n plus 1 over n plus 1 factorial, and then we times the inverted function n factorial over 2 to the power of n. This is because we have to divide it, so to make it short we just invert it. So here we get limit n to infinity again. So I make it much simpler, 2 to the power of n times 2 to the power of 1 over 2n to the power of n times n factorial over this one. I will make it as n factorial n plus 1. So this is just rearrangement. Then I cancel out. So we will get 2 limit n to infinity 1 over n plus 1. So if we insert the limit, we will get zero. As 0 is less than 1, therefore the function 2 to the power of n over n factorial we can conclude that it is converged. So that's all. So this is the second example. As usual, we put out the limit n is to infinity. Three n plus 1 and then plus 2 over ln n plus 1. Then we times the ln 1 over 3n plus 2. Sorry, 3 to the power of n plus 2. Okay, so we just rearrange it and make it more simpler. And then times ln n over ln n plus 1. After that, we can cancel out. So we put 3 in front because it is constant. Then we'll get ln n over ln n plus 1. Then continue. 1 over n over 1 over n plus 1. We differentiate it using L'Hopital rule. And then we continue. 1 over n times n plus 1 over 1. So we will get 3 limit to the n to the infinity n plus 1 over n. Then we divide it with n. So we will get 1 plus 1 over n. If we insert limit to the 1 over n, we will get 0. Therefore, 3 times 1 plus 0 we will get 3. Therefore, 3 is greater than 1. As 3 is greater than 1, we can conclude that three to the power of n plus 2 over ln n is diverge. Second one is root test. The formula is an to the square root of n, and we get the answer as p. If p is less than 1, it is converge. If it's more than 1, it is diverge. If equals to 1, therefore it is inconclusive. In the third example, we will solve this by using root test. So we started with limit n to infinity for n over 3n to the power of n, and then we square it with n. And then we continue, limit to infinity for n over 3n to the power of n. The root, we will change it 1 over n. Then we solve it. Still, we continue, limit to the infinity. Then we get 4 over 3n. And then we put 4 over 3 at the front as it is constant. And we insert limit n is to infinity into 1 over n. And then this will get 0. Therefore, 4 over 3 times 0 will get 0. As 0 is less than 1, therefore we can conclude that 4n 4 to the power of n over 3n to the power of n, it is converge. In this fourth example, we will also be doing root test. So we continue. We start from limit n to the infinity 4n plus 3 over 3n minus 5. And then we make it to the power of n. Don't forget to make it to the root of n, but we just change it to the 1 over n. And then we solve this. We will get 4n plus 3 over 3n minus 5. And then we continue to divide each of it with n. So we will get limit to the infinity, n to the infinity, 4 plus 3 over n over 3 minus 5 over n. And then if we insert it the limit, we'll get 4 over 3. So 4 over 3 is greater than 1. As it is greater than 1, we can conclude that 4n plus 3 over 3n minus 5 and the whole series to the power of n is diverge. So that's all. Thank you for watching.